NanoServer is still in technical preview. As such, its name could change before the final release date. Its original code name was Tuva, spelled T-U-V-A, so the name still could change. NanoServer is born of the requirements and limitations of a full server. A full server is one where we've got the local GUI management capabilities, which increases the resource utilization on that host and potentially even the attack surface because there's more running. So we want to offer the services that a traditional server can offer over the network, but we want to have a more lightweight footprint. So NanoServer then is well suited as a virtualization or an application server in a data center because it can scale well. A full Windows Server image or virtual hard disk could equal out to approximately 8.3 gigabytes. If we do that remote installation over a network, then we're consuming network bandwidth, and that's only for a single server image or single virtual hard disk. If we perform live virtual machine migrations from one Hyper-V host to another, that still results in network traffic. Even though we're not migrating the storage, we're still migrating a memory map file that's equivalent to the size of the RAM allocated to that VM guest. So given enough virtual machines that have to be drained from a Hyper-V host and live migrated elsewhere, that could turn out to be a lot of network bandwidth. Then we have to store server image files that are really much larger than they need to be. In the past, with the Windows Server operating system, all of the source files for roles and features were installed along with your installation of the operating system, even if you never used them. So that needlessly wasted space. That's no longer the case anymore, and it's one of the many reasons why NanoServer is very small and efficient. Some patches applied to the Windows Server operating system or applications running within it require a reboot. And so the more that we have installed, the more the potential is for reboots after having applied patches. It seems like a waste if some of those patched components might never be used. And reboots take time. So on a virtual machine host, if we have to do a reboot, that means we have to live migrate virtual machine workloads to another host elsewhere, patch the local VM host, reboot it, and then live migrate the workload back. So whether we're talking about a public or a private cloud, this seems like a waste of time and resources. And it is. This won't be as necessary with NanoServer due to the reduction of the number of reboots. Microsoft's target is to have up to 2 reboots required per year. On the security side, a full operating system installation has a potentially larger attack surface because there's more installed and more running. In the past, all roles and feature files were stored on the hard disk, even if they were never used. That also means that patches were applied. Having a local graphical user interface or GUI can be problematic on a server. Servers should really perform server functions and not desktop functions. So we need to isolate the client stack from the server stack. And that's the direction that Microsoft is heading in, which is definitely exemplified here with NanoServer. NanoServer has no local interface at all in any way, shape, or form. So it's designed to be managed remotely over the network. Virtual machine density is lower with higher resource utilization on a full operating system install. So the less that we have running, the more virtual machines we could potentially run. So with NanoServer, we have more efficiency with a lower cost. In this video, we discussed the need for NanoServer.